Hello there. We introduce MVP of the UrsusOnline, a new Provendo product enabling independent and automatic verification of properties of smart contracts written in the Solidity and Rust languages for developers, auditors, and security analysts. UrsusOnline helps to shift from bug search to correctness prove, helping engineers to stop guessing where the mistake is. Our product is built on the Cock-proof assistant, but we have significantly enhanced it with expansions in syntax, proof search, and code generation. Specifically for verification, we have developed the Ursus language. It resembles imperative languages, but is compatible with Cock and empowers us with Cock-proof techniques. Ursus Online helps with eliminating bugs, uncertainty about program behavior in corner cases, and with untested values of variables, improving clarity of the used software structures and logic. During this demonstration, we will walk through all the key stages of the pipeline using a real-life scenario. First, you need to create a session to work with the contract. Next, you need to select the file with the contract's source code. For this demonstration, we have selected the implementation of the ERC20 token standard, written in Solidity. This is a widely used contract for the Ethereum blockchain. It enables the creation of customized tokens and cryptocurrencies on this blockchain. After the source code is uploaded, it is essential to translate the source code into a form suitable for verification, Ursus language. Translated grammatical constructions in Ursus are equivalent to constructions in Solidity, since the translation is based on the correspondence between abstract syntax trees of languages. Then compile the translated code. And get Ursus meta, gathering meta information, such as information about the contract functions and their arguments. This information will be used by the property constructor in the next steps. We need exec to continue the verification process. Essentially, exec is a mathematical form of function reduced to a unified format, equivalent to the original function. Our tools accept only such forms of functions, and the equivalence of exec and the original form of function is automatically formally proved during generation. We will create exec for the transfer function. Now let's focus on the most important part, the formulation of the property that will be proved, also known as the formal specification, a set of requirements for the behavior of the function and defined by the developer. This property is dedicated to the correctness of the transfer function. We could choose any other function here. To start, you need to determine contract fields and other state variables that will be involved in this property. We are interested in the sender of the transfer, the balance of the sender before the transfer execution, the balance of the recipient before and after the transfer execution. Let's add some basic restrictions on function arguments. The sender and recipient shouldn't match, and the sender should have sufficient funds. Then we expect that the recipient's balance will increase precisely by the transfer function's argument value, and we're going to prove it. The Code tab displays the Cock code generated based on the user's property description. Now we can send it to the server. We have successfully developed a mathematical model that represents the transfer function under specific conditions. Now we can verify correspondence of the contract code to this model using the Cock-proof assistant built into UrsusOnline. And if we get formal proof, that means the code corresponds to the designed model 100%. In other words, the program behaves as intended in any possible case, irrespective of the variables' values. Let's compile the formulated property. We will submit this property for proof. As UrsusOnline employs the Ursus Prove automatic proof algorithm, the proof takes just a few minutes, given the current state of technology, and ongoing optimization efforts enhance efficiency further. We received a message that the property has been proven. Now we can be sure that it is true. Everything you need to use Ursus Online Pipeline successfully is a clear understanding of what your program is intended to do, since the only required action is formulating properties in the constructor of the add proposition clause. In case of success of the proof, you can be sure that the program is 100% predictable and will not behave unexpectedly in any corner case. Also, you don't have to trust our algorithms and techniques because the proof is not just a text on the screen. It is an artifact file, which is suitable for independent formal verification using a proof assistant. This helps to exclude the expertise and reputation factors of the verifier, shifting responsibility for quality and security checks from the engineer to the algorithm. Thank you for your attention. We hope you're interested in Ursus Online. Stay in touch with us on socials. It will be out soon.